Trigonometry, Chapter 10, Section 3, Vectors and their applications. So a few basic terms. First of all, a scalar refers to a magnitude. For example, 45 pounds would be a scalar. A vector quantity is a magnitude with direction. So in other words, you have an amount and it's going in a particular direction. For example, 50 miles per hour east. So you add the direction onto it. Vectors are generally represented in boldface type with an arrow over the letters, or with an arrow over the letters. So you have two examples here, boldface OP and OP with the arrow. Both of those represent vector OP. The first is the starting point. The second is the point it goes through. So the first letter is the initial point, as I just said. The second letter is the terminal point, where it ends. Notice we have two vectors here. We have OP and PO. Those are not the same vectors. They are, in fact, opposite. They have the same magnitude. The magnitude, by the way, is represented by the length of the vector, but they are going in opposite directions. Two vectors are equal if and only if they have the same magnitude and the same direction. You can add vectors together. How you do that is you place the initial point of B at the terminal point of A. The vector with the same initial point as A and the same terminal point of B is the sum A plus B. And the parallelogram rule says to place vectors so their initial points coincide and then complete a parallelogram. Okay, the first picture here is method 1, placing the initial point of B at the terminal point of A, and then the diagonal there, the red diagonal, is A plus B. The second method is to put them so their two initial points are together, construct a parallelogram using those two as sides, and the diagonal there is A plus B, and you'll notice it's the same either way you go. Vectors are commutative, so A plus B equals B plus A. The sum is called the resultant. For every vector, there is a vector negative v such that v plus negative v equals 0, which is called the zero vector. In other words, if you add a vector and its opposite, you get 0. The scalar product of a real number, which is a scalar, and a vector u, so k and u, is the vector k times u. Has a magnitude of k times the magnitude of u. If k is negative, then ku is in the opposite direction as u. In other words, if you have a vector that's u and you multiply it by 2, then it is 2u and it is twice the length of the original. If you multiply u by 3/2, the result is 3/2 the length of the original. If you multiply it by a negative number, like -2, it's twice the length, but it goes in the opposite direction, as you see illustrated here. A vector with its initial point at the origin is called a position vector. A position vector u with endpoint AB is written as u, and then you have AB in they're not really parentheses, they're kind of like pointy parentheses. A is called the horizontal component, and B is the vertical component, kind of like X and Y. The magnitude or length of the vector is given by this formula. This is on your formula sheet. Notice that to indicate magnitude of a vector, we put it in, it looks like absolute value bars. And you're going to square the two components, add them together, and take the square root. Now, the direction is given by an angle, usually, and it satisfies the equation tangent of theta equals b over a, where a is not equal to 0. So you find the length of the vector by squaring the components, adding them, and taking the square root. You find the direction of the vector by doing b over a, the vertical over the horizontal, and doing the inverse tangent. That will give you the angle that the vector is directed in. The magnitude and direction angle for vector u. Pause the recording, give it a try, resume to check your answer. Okay, analytic solution, what they did here is they graphed it. Notice it starts at 0, 0, it ends at 3, -2. And you can kind of look at that and figure out the angle. You can make a triangle and figure out the angle. You can use the Pythagorean theorem and figure out the side length. Using our formulas, though, we have 3 squared plus -2 squared. We have the square root of 13 for the magnitude. Y over x, or b over a, is negative 2/3, and the inverse tangent of that is negative 33.7. Now, we do want to have a positive angle there, so we add 360 to that, and we get 326.3. Okay, finding our horizontal and vertical components. The horizontal and vertical components, respectively, of vector u having a magnitude of u and direction angle theta are given by a equals the magnitude of u times the cosine theta, and b equals the magnitude of u times the sine theta. This should look really familiar because when we did the unit circle and everything, the x value was represented by the cosine, the y value was the sine. Here we have basically the same idea. So you're going to do the magnitude of the vector times the cosine. That will give you the horizontal, the horizontal component, and the magnitude times the sine will give you the vertical component. So here's another way of writing it. So here's an example of what we're talking about. If you look at the triangle there, the horizontal component, to get that, what you would do is you would multiply 25, which is the magnitude of w, times the cosine of 41.7 and get 18.7. And to find the vertical component b, you would multiply, again, the magnitude of w, which is 25, times the sine of 41.7 and get 16.6. And now you're gonna write vectors in the form AB. So we've got, we've got two vectors there. We've got U and we've got W. So use what we just talked about. Pause the recording. Oh, and we've got V also, sorry. So we've got U, V, and W. Pause the recording, give this a try, and resume to check your answer. Okay, so U is going to be 5 cosine 60 times 5 sine of 60. You see the answer there. To get V, you're going to do 2 cosine 180 and 2 sine of 180. And then to get W, you're going to do 6 cosine of 280 and 6 sine of 280. And you see the answers there. A few properties of parallelograms which can help us with vectors. A parallelogram is a quadrilateral whose opposite sides are parallel. The opposite sides and angles of a parallelogram are equal, and adjacent angles are supplementary. The diagonals of a parallelogram bisect each other, in other words, cut each other in half, but do not necessarily bisect the angles. They don't necessarily cut the angles. And let's try this problem. Read over the problem, pause the recording, give it a try, and resume to check your answer. Again, we're going to be mostly just dealing with triangles again. So from the figure, the angles of the parallelogram adjacent to angle P each measure 80 degrees since they are supplementary to angle P. Angle P is 100, angle R has to be also 100. All of the angles have to total in a parallelogram 360, so that leaves 80 for both Q and S. The two resultant forces divide the parallelogram into two triangles, so you can use the law of cosines on the triangles. Now, we don't know the angles that P is split into, but we do have enough information in order to use our law of cosines to solve this. So V squared, magnitude of V is going to be 15 squared plus 22 squared minus 2 times 15 times 22 cosine 80, which is about 24 newtons. Okay, a few things about vector operations. You see the addition property there. If you have AB plus CD, it's A plus C, B plus D. It kind of distributes if you're multiplying by a scalar. You have opposite vectors, and the opposite vector has the same A and B but different signs. And then you have a subtraction rule as well. Now let's try those vector operations on this example. Pause the recording, give it a try, and resume to check your answer. Okay, when you add U plus V, you just add the A's and you add the B's, and you get 2, 4. -2 times u is just simply -2 times -2 and -2 times 1. And then 3u minus 2v, not much more complicated. We get -14, -3. Now, a unit vector is a vector with a magnitude of 1. And two very useful unit vectors are I and j. I is the vector 1, 0, and j is the vector 0, 1. And we can define everything in terms of the unit vectors. So v is ab, then we can write it as ai plus bj. In other words, the component a times I unit vector plus the component b times the j unit vector. Okay, a dot product of two vectors, u and v, is denoted as u dot v, and here's how you figure it out. You do a times c plus b times d. So the dot product, you get a single number answer. This is on your formula sheet, by the way. So if we want to find this dot product, we're going to do 2 times 4. We're going to do 3 times -1, and we're going to add the result together and get 5. Some properties. First of all, u dot v equals v dot u, so there is a commutative aspect. U dot v plus w is u dot v times u dot w plus u dot w, so it is distributive. This is the same thing, just rearranged. Ku dot v is the same as k times u dot v, or u times k, or u dot kv. The zero vector times any vector is the zero vector. That's no big surprise there. When you do a dot product of a vector with itself, you get its magnitude score. Geometrically, if theta is the angle between two non-zero vectors, where theta is between 0 and 180, then u dot v is the same thing as the magnitude of u times the magnitude of v times the cosine of theta, or the cosine of theta is u dot v over the magnitude of u times the magnitude of v. So this is a way of finding the angle if we have two vectors and we can find their dot product, we can find their magnitudes. We can then find theta. So try it with this one. Now these formulas are on your formula sheet, so give this a try. You're going to solve for theta. Pause the recording, give it a go, and resume to check your answer. Okay, we're just using the formula. We've got 34.21 over the magnitude of 34 times the magnitude of 21. And we just put those into the formulas. And we get 10 over 5 square root of 5, which is about 0.8944279191. That's the cosine, so you're going to do second cosine, and you get 26.57 degrees. Notice that if a dot b is 0, then the cosine is 0, and the angle is 90, which means that the a and b are perpendicular, or they are orthogonal vectors. Okay, now we're going to do a navigation problem. Now you may want to try this on your own. If so, go ahead and pause the recording now and resume when you're ready. If not, we'll talk our way through this. So we have a plane with an airspeed of 192 miles per hour. It's headed on a bearing of 121 degrees. The north wind is blowing from north to south at 15.9. Find the ground speed and the actual bearing of the plane. Now, when we do these problems, you got to realize you're going to have two speeds and two bearings. One is from the perspective of the pilot in the plane. The pilot in the plane has the plane set going at a certain speed and has the plane set to a certain bearing. Outside of the plane, you have a wind blowing that is pushing the plane. It may be pushing it faster, it may be pushing it back. It's probably going to be pushing it off of its bearing. So the ground speed and the actual bearing refer to the actual speed of the plane and actual bearing of the plane under the influence of the wind that is blowing. So those are going to be our two vectors, the airspeed, the bearing and the airspeed from the pilot's perspective, and the ground speed and the bearing that has taken into account the effect of the wind. The wind will be our other vector, making the third side of our triangle. So here's what this is going to look like. Okay, the plane, as far as the pilot's concerned, is on a bearing of 121 degrees. So starting from north, measure clockwise 121 degrees, and then draw your vector, and that is 192 miles per hour. So that's the magnitude of the vector. Now notice at the end of that vector, which goes from O to C, we have a south vector of 15.9. That represents the wind speed. Then we have another vector going from O to B, and that represents the actual bearing and the actual ground speed of the plane. And that's what we need to find. The angle in between OC and OB has been labeled as alpha. Now the first thing we need to understand is that the O to N, that vector going north, and the vector CB are parallel to each other. Okay, one of the rules you learned in geometry is that when a transversal crosses parallel lines, alternate interior angles are congruent, which means angle C is 121 degrees because angle C is an alternate interior angle to angle AOC. So knowing that angle C is 121 degrees, and then we have that OC is 192 and CB is 15.9, we can find the vector, the magnitude of vector x. So we do the magnitude squared, and we use the law of cosines. So the formula you see there is putting in the law of cosines, and we get that x is 200.7 miles per hour. So even though the pilot's got the plane set at 192 miles per hour, and as far as the plane itself is concerned, that's how fast it's going, because of the wind, it is actually going 200.7 miles per hour. Now we need to find alpha. So we're going to use the law of sines. And when we use the law of sines, we discover that alpha is 3.89 degrees. So the bearing of the plane is, you actually need to add that. It's 121 plus 3.89 degrees, which is going to give you 124. Okay, here's another problem. Now, guys, illustration is really important. And remember, we're just dealing with triangles. If you want to try this on your own, pause the recording. If not, keep it going, and we'll go through this. So we have a force. We need to know the force required to pull a wagon weighing 50 pounds up a ramp inclined at 20 degrees to the horizontal, assuming there is no friction. So here's our illustration. So you have the wagon. You have the ramp. Notice that E is 20 degrees. Well, again, what we've got here are similar triangles, and if you want to in class, I can demonstrate why they're similar triangles. But angle E and the angle ABC are both 20 degrees. Those are going to be identical. The downward vector there that's labeled 50 is the weight of the wagon. A to C represents the force required to move the wagon up the ramp. And then you've got a right angle there. It's going to be at a right angle to the vector drawn BC. So we make a right triangle, and once you kind of get that down, if you can get the illustration down and get your triangle labeled, then it's just a matter of dealing with law of sines or law of cosines. So what we're trying to find is we're trying to find AC. Well, we know that the sine of AC, we're dealing with a right triangle here. So we know that the sine of 20 degrees is going to be AC over 50. And we just solve that, and we get 2,017 pounds. All right, the rest of this is additional practice, so if you will give these a try, pause the recording as you do it, and resume to check your answers, and do that through the end of the recording.